When major appliances such as your dryer breaks down, it's usually a painful experience. In the summertime you have at least the option of drying using solar energy and wind, but it doesn't work for the other three seasons. So in this video I will review some of the repair options that you have when it comes to a dryer. This one is a 1982 or so estimated special, but all dryers work using the same principles. They have a door. I just took it off. There's a drum inside. The drum spins, air is being exchanged over the clothes, and there is some kind of controls on it. So even if your dryer looks different and is digital and fancy and has an LCD and more push button and it beeps and whatever, yeah, it's the same dryer. It's the same dryer. It has a drum. The drum spins. The spinning drum is driven by some kind of a V-belt. The drum must have a bearing somehow that provides the rotation, and the air exchange over the drying clothes must be done doing some or using some duct work. The same motor, there's some duct work from the back here, the same duct work that the same motor that exchanges the air over the clothes also spins the drum. So they really haven't changed that much over the last, I don't know, 50 years or so. So a dryer is a dryer. Just for the record, this one has been donated to me and is an Inglis Niagara dryer, and that's its controls. This is a turn dial for temperature setting. This is for the buzzer. This is some kind of dial for drying time that can be changed, and I don't have the manual. And this is the only other label that this dryer comes with. So with that said, let's get going. What can be repaired on this and what can go wrong? Well, what went wrong with this, it was spinning and spinning and spinning and never switching off, and just kept going and kept going, and the clothes took forever to dry and just kept going and kept going. Alright, so in terms of repair options, other than obviously taking it to a service technician and get it serviced, we'll go from simple and easy and not too technical to more involved to even more involved. So what happens when the control buttons break or malfunction? They're very simple. We'll look at some of your repair options here while everything is open. And another one is, of course, cleaning the machine, cleaning up this dryer lint that covers the heater element, that covers the thermostats, and that doesn't need a technician to undo a couple of screws, and for removing the back panel and just cleaning up the lint. The lint can stop this machine from functioning properly, and then we'll get to the bearing and V-belt and the motor and the more involved stuff that's not so easy to access. So let's get started with the straightforward items, because there are just a handful of pieces that can go wrong in a dryer. It's really no rocket science. Come on up here on this tripod. This dryer happens to come with this diagram on the back of the dryer that tells you what components are there in the circuit besides the mechanical parts that I've just shown you for anecdotal, the belt and the bearing and that kind of stuff. So it can work either on 120 volts between these 2 points, and so for 120 this is the circuit, and for 220 this is the circuit, just goes there. So if we just read some of these, I'm gonna do the reading here, then you kind of get an idea of what kind of components are in here. This one reads buzzer, and it's got 2 wires going into it. This one says start SW, start switch. That one reads motor. That one reads center switch. Probably just like on a motorcycle, a tip-over sensor. I'm guessing. We'll dig it out and take a look, see what we find. What do we have here? Belt switch. It says belt SW. This one says door switch. This one says timer motor. TM1, TM, some kind of timer motor. The over here it says heater element thermostat. That's fairly straightforward. It's a snap action thermostat. I'll show you. This one is this Ziggy line here is a heater element, 5200 watts. So there's your wattage for it. And then you have a temperature thermostat. That's another switch. Every thermostat is just a switch. Just heat activated, not flipping activated. And you have one more thing here, temperature select. So the dial that you saw at the front kind of corresponds to those 3 positions there. Fairly straightforward. That's all the components. I can see some patents listed here. It says, notice manufactured under one or more of the following Canadian patents: 1968, 69, 70, 71, 2, 3, 4, 7, 8. So that's the last one listed, so that's why I'm guessing it's not older than 1978. So my reasonable guess here is 1982. Let's get started here. What we've got is, given the complexity of the machine, I have just removed, of course, this back panel, which was just simply there where the cold air duct hooks up, and this skinny sheet metal piece, of course, was covering there the back side of the control panel. And over here you can see that the push button for the buzzer on off is just very simple, 3 pieces of wire. This was the control for the temperature 3-position switch. This is the buzzer with 2 wires. This one looks a little more complex, so if anything goes wrong in terms of instrumentation, these ones are easy to replace as a whole unit. Undo 2 screws, pull off these little connectors there, that's how much effort it takes, and replace it with a new one. Of course, you need to pull off the knob from the front. These knobs just come off like so with a little more force. Okay, I don't want to bust my fingers, but you get the idea. These are super easy to replace, and you need to remove like 4 screws from the corners, 1, 2, 3, 4 from the other one. Done. These are accessible and fairly easy to exchange those if any of those should fail. Further down here, what you're looking at, this ductwork that I mentioned before. The dryer is taking in cold air from just here. Whatever comes through the slots of the back takes in cold air from here. And what you see underneath there is a heater element, which looks like there. Those coils, I'm going to take them out and open it up. Those coils are the heater element. They heat up the air that's being sucked in, driven by the airflow, of course, is driven by the motor. You don't see the motor just yet. But so that's the heater element. The airflow is provided by the spinning motor. The air goes through here, gets heated up, and over here enters the drum. Once it's in the drum, the clothes will cool down the air, especially wet clothes. Dry clothes will cool down this heated air a lot less, and the exhaust air, or the cold air exit, is through here, and this is where you hook up your cold air duct. Now, if there is a lot of difference in temperature between this air and this air, if there's a lot of difference in temperature, then the clothes are damp, cooling the air down. If the exhaust air is about the same temperature as one being heated up and that enters the dryer, then the clothes are dry. I hope that makes sense. because dry clothes don't change the temperature of the air significantly, and when the two thermostats, one is seated here and the other one is seated there, when the two thermostats read about the same temperature, then clothes are dry and everything switches off. So in this dryer's case, it was spinning and spinning, so the motor is fine, the belt is fine, and the bearings are fine. What isn't fine is something to do with controls. Not the control buttons, but something with the automation that senses temperature and shuts off everything. The reason for these thermostats for not function is, we're gonna take a close look at that, but before we is this fuzz, lint from the dryer that covers everything, is the reason why some of these sensors may not function. This thermostat was here, let me just grab its base plate. There, with its base plate and everything, they were just mounted here. This is the exhaust air thermostat. This is a snap action disc thermostat. It's got a fancy base plate here that doesn't need to be replaced, that's just there. And there is the snap action thermostat itself. This is how it looks like, and it was covered with fuzz everywhere. The problem with it is that this thermostat the fuzz is an insulator material, and this thermostat needs to heat up in order to switch off the power from going to the motor. So if this insulating thick layer of fuzz is covering this one, of course it's not gonna sense the temperature very well. I have another video about the details of the snap action auto reset or manual reset. Either way, thermostat, it's got a disc in it. That disc can also fail along its edge. The edge is glued inside there, and it's not really user serviceable, but I'm sure it's within your mechanical abilities to undo two screws to access the thermostat and get one from your parts supplier and get this one sorted out if these thermostats need changing. What the thermostats of course do again is they turn the machine off, they turn the motor off when the clothes are dry. So replacing them is fairly straightforward, and they actually cost about $2, $3, $5, some such thing. Now your Inglis or whatever, Bosch, whatever dryer you have, your original equipment manufacturer might charge you $50 for a thermostat, but the thermostats are not made by Inglis or Whirlpool or Bosch or Sears or whatever. They are very simple, one-of-a-kind, mass-produced thermostats that you can replace if you can take off this fancy base plate. The base plate is crimped. You can see a single dimple there, and one on the opposite side that hold this base plate on the thermostat. Okay, there's a third one there. So if you can loosen it up somehow at the dimples and take it off, I will take it off so I can show you the different parts in pieces. So a thermostat such as this without its base plate is really cheap. I know it's upside down, but it's got some numbers on it, and once you figure out at what specifications these thermostats have in terms of temperature cutoff, there's some more letters, thermo disc, that's what it says. Other than that, it's got some numbers on it. So once you figure out at exactly what temperature these snap action thermostats open the circuit and therefore stop the motor, then you can just get these. You don't have to necessarily rely on original equipment manufacturers. Usually 4, 5, 800% profit set prices are found on these pieces. The other thermostat, of course, was here, which is mounted with those two screws there into that spot, also covered with fuzz and lint and a layer of crud and who knows what that interfere with its operation. And the last two pieces of wire there, they just go to these two plates here, and of course they power the heater coil that we looked at. The one more item that we can look at, this was going to the front underneath the top of the machine, and this is a very simple switch. This is a door switch, and the complexity that it involves to replace one of these door switches, should your door switch malfunction for whatever reason, is also very simple. Pull off these connectors there, no tools needed, absolutely no tools, and just replace a push button switch just like this. Super straightforward. And this switch was just mounted here, sticking out there, so when the door, which was mounted right around here, this is the hinge screws there and there, so when the door closes, then that plunger on the switch gets pressed, and that's how this door with its hinge and that switch was working. Very straightforward. So what I'm gonna do is keep on digging, get to the motor, and find some more components of this harness, and we'll tell you about some more repair options that you have. So I opened up everything. I had to cut it up with a grinder because the housing is spot welded together in numerous places, so it's really hard to get access to everything that's inside. So let's get started with the straightforward pieces here. Just a hollow piece of sheet metal, just like so. There's nothing in it. There's no moving components, nothing to look at. Same for this one. Was held by a single screw, and I took out the heater element so that it's hollow. I'll show you the heater element. Very straightforward. It looks like this. This one is not fuzzy. It looks good enough, even though it looked dirty when we looked in from the underside. Yeah, the dangling dirt on it wasn't looking too promising, but after all, that's all the dirt that's on it. Just that one there, and besides that, so this one's looking in pretty good condition. In a separate video, I'll show you how to test the heater to make sure that the reason why your dryer keeps running and never dries your clothes is not the heater. It doesn't. You don't need to remove it. Testing will be done just using these two electrical connection points for it on the bottom, so it doesn't need to be removed, and it's fairly easy to test it. I'll show you a separate video. So just put it there and save it. And of course, like I said, so air is being taken through that heater element, goes into the drum there, and the drum doesn't have a back panel. The back panel is this, so the drum just spins there, held in place by these two small wheels, and the spent air exits here, or the damp air exits, or cold air, sorry, exits here, and just here is the fan that's powering it, and this fan of course is mounted on the same shaft as the motor is there. So this, and the motor of course, other than spinning the fan on that side, has another spindle on this side with grooves on it. These grooves of course correspond to the V-belt that drives the drum. I'll show you. The V-belt runs here on the middle of the drum. You can see the the print on it, and since 1982 this V-belt dried out a lot, so this can go wrong. Let me just get you a nice picture on this. There, now you can see how the edge is crumbly and cracked. Alright, and it has, let me just get a different shot, different light here. How about over my hand here? There, it's cracked up everywhere. Alright, it shouldn't have these lines crossing the V-belt this way. There, now it's right against the lens. Okay, so this V-belt is basically a throwaway. When you check it out like this, make sure you check it in good light. Now in normal operation these cracks are not opened, it runs with these V grooves facing the drum, so this is what you see from the outside. You don't see the cracks. You have to remove the belt and bend it a little bit like so. Alright, so that's garbage, and that can fail, and it's not easy to access. Even though belts are reasonably priced, like I said, I had to cut this one up to access the V-belt fast enough for my liking, so you would need to figure out some civilized access to this V-belt. I did not remove any of this fuzz here other than whatever amount tumbled over. You can see how this fuzz covers the electrical components and can stop this motor from functioning. It's running fine as is, but it can interfere with electronics as well as it interferes with bearings usually. Now I'm gonna show you an easy one here, where that one bearing that balances the drum. So far so good, the bearing spins here, but if I push it back in place, now it doesn't. And you see the fuzz, whatever fuzz was gathered over here on the spindle, whatever happened here, the thickening of the spindle is enough to stop it from spinning easily. Now it will still spin, especially if you put 10 pounds of wet clothes in the drum, but you see how these bearings deteriorate due to this drier lint. There are also bearings here on the motor's arbor. This is the motor's rotating shaft, and it's rotating really nicely. You can see with minimal effort, it's fantastically well working. And there is a bearing there, and there is a bearing at the tail end of the motor, ball bearings, so it's critical that these not clog and work. If you need to rewire the motor because the motor itself fails, then in that case it neither has airflow from this fan on the other side, and nor does it spin the drum, so motor failure is fairly easy to diagnose. And one more thing I want to point out is this feature here, this wheel here. Now this wheel is just a tensioning wheel because the belt is looped around the arbor's motor and comes out here and then goes around the drum. So, but there is this tip over switch. This, you can hear it clicking, and it's a long lever switch. It's fairly straightforward how it works. This is where it's located. Alright, this is, sorry, not the tip over switch, this is the belt switch. Alright, if should the belt break, then this, let me think it through. Anyhow, this is a switch that you have here. Let me see if, yeah, when there is tension on the belt, it's in this position, and if the belt breaks, it springs out in this position here. Alright, so that's basically what I found. I need to do some more, I need some compressed air to clean this motor, and then we can look at it briefly. So that's basically, these basically are repairs that are difficult to access, and you might want to give it to a technician. With the motor out and cleaned, I just have a couple of electrical and mechanical notes on this dryer here. You see this groove here on the drum? That's where these wheels run, and it's fairly straightforward to see that if these wheels seize up due to the lint accumulation around the wheel, then this V-belt that drives it is gonna spin, or it might overload the motor and fries the motor. If that motor burns out, that's a whole lot of digging to replace that. It may not be worth your while to replace it. So that's how a simple lint issue can lead to a widespread costly breakdown. And those wheels and bushings and bearings on those little wheels are not really easily serviceable either, even though in principle it's very simple to clean it. Some of the stuff I have here is just felt pads. This is not lint, it just looks like it. These felt pads are around, let me just get you a nice picture about it. There, these felt pads are around the front of the drum there, and this band is around this part. It was glued to the metal there, so not everything you see is necessarily lint. And oh yeah, and here is of course this one too. So some of it is foam, some of it is lint, so don't just be ripping everything out. So this is foam stuff. Lastly, on this motor, I cleaned everything. It's not just a motor, you can see it says it's thermally protected motor. Let me just rotate you. They're thermally protected, and it was made in the days when stuff wasn't made in China and there were motor winding technicians around in North America. The last of them probably died out 10 years ago, and you can see some switchgear and some other stuff in it, as well as something that there with some spring-loaded stuff in the middle of it. So this is not just a simple motor. If this needs replacement because it burns out, because of any of those bearings seize the drum or seize the motor, then this is gonna be costly, because it's not just a straightforward motor. So that's how the lay of the land looks like. Of course, the decision ultimately is yours. I have cleaned the bearings of this motor, and I will shoot a separate video on it. Partially, I already have some of this footage done when I directed compressed air in here. Pink fluffy stuff flew everywhere, such as this one there. Grease or lubricant impregnated chunks of felt. So this is felt insulated, or felt lubricated, a permanent lubrication provided by felt. I've got a separate video on it already that I shot on a sewing machine, where lubrication was done likewise permanently for the lifetime of the bearing through lubricated felt pads. So I will also take this one apart and see if I can make a video out of it. That's basically all I wanted to share about dryer repair options.